All femtosecond lasers work on a principle of photodisruption, but the ZEMA system using nanojoule pulse energy works as the driver to the mechanism of actually causing the separation of corneal tissue, the photodisruptive effect, as opposed to using a photocavitation effect that a lot of high energy femtosecond lasers use. And this is the big difference between the lasers. So when we basically think about this in terms that most people can understand, it's like going into a very hot bath for basically 10 minutes as opposed to a very lukewarm bath or a cold bath maybe for an hour, which most people can tolerate that lower temperature rather than the hot temperature that we see with the higher femtosecond lasers. We've had some preliminary experience using the lenticule extraction with the ZEMA laser. I think it offers a few advantages over other laser systems. One of the nice things is that you can actually move the lenticule and help you with centration after the docking has basically occurred, which is a big advantage because we know that during lenticule extraction it is important to get the accuracy of the lenticule in the right position on the visual axis. The docking with the ZEMA system is in the same handpiece that we basically use for LASIK, so it's a flat applanating system. There's a lot of software manipulation that can be done with the ZEMA system, so we can make different tunnels. You can use 2 tunnels, you can use 1 tunnel, and you can make the tunnels at any size you want. This may be important in the future when we're thinking about doing toric and astigmatic corrections where we can alter the tunnel length. The advantage of also being able to make 2 tunnels is that for less experienced surgeons who are new to lenticule extraction, it will help them remove the lenticule from the eye itself. So this can all be tweaked during basically the software when people are undergoing the surgical procedure itself. For more experienced surgeons, they may find it easier to just use 1 incision, which is what I currently basically use, and also it allows you to adjust the incision size so you can reduce the amount of surgically induced astigmatism, and we can basically improve the biomechanical effects on the cornea by making our vertical incision much smaller.